Hungary this year marks the 10th anniversary of Lewis's first hybrid victory, Hungary 2009, with the KERS system that was introduced that year. This is the KERS system that helped Lewis win that race. He stored the energy up going down the straight. He didn't deploy it down that main straight. He hung on tight using all that energy and then deployed it out of turn 2 and overtook to win the race, using the energy stored in this energy store. The development journey of the energy store, the power electronics and the 60 kilowatt electric motor, it started 2 years before. This is the development system of the power electronics that we ran in testing in 2008. So we transitioned from something this size through to this for racing. But then 2 years later, when KERS returned in 2011, we'd taken these two units and combined them into this single box, where we had the energy store system, the control electronics, and all the computation to manage it. This has then evolved in 2014 into a slightly larger box, but it's got double the energy stored in it, 3 times the amount of power that can be delivered, 2 inverters, and significantly more processing power. 2009 KERS system, so kinetic energy recovery system. Today we would call that a regenerative braking system, so recovering waste energy from the car, the mass and the velocity of the car, recovering that energy through an electric machine, energy converted in the power electronics and then stored in the cells of the energy store, and then using that energy to then propel the car as the car then accelerates. A regenerative braking system today in all hybrid cars is something that makes you go further with the same amount of energy. The KERS system developed for 2009 was developing exactly the same technology. In motorsport, we use it to go quicker. In the road car world, you use it to go further with the same amount of fuel. During this journey, the energy store changed from something that weighed 100 kilos, the early systems. We've reduced it by 81%. We're now all the way down to the minimum FIA regulation of 20 kilos. In that journey as well, the energy density's increased. That's increased 12-fold. So the amount of energy that we can put in a single cell has increased by 12-fold. And the power, 200 kilowatts that can be deployed by today's ERS energy store at just 20 kilograms of weight. That development journey is quite incredible. The development journey of the energy store has also involved an increase in voltage. The higher you go in voltage, the lower the current for the same amount of power. And it's the current that causes the losses, current to the power 2. So reducing those losses, increasing the voltage. We're now just less than 1000 volts with the ERS battery. That's a journey that the road car world is also taking. A lot of the current systems operate at 400 volts. A few years' time, we'll see them go up to 800 volts and then get close to the 1000 volt mark. All of this development work that goes on in Formula One does help feed into the learning journey that takes place in the road car world. The battery development that went into the KERS system for 2009, where we were focusing on energy density, we were focusing on efficiency. That work that was raced in 2009 was then used to develop the battery for the AMG SLS electric drive. Motorsport technology then going into high-end road car work.